All right, ladies and gentlemen, we have a request to do a mechanism from the W20 T2 Part 4, 6H. We have a Grignard reagent going to react with an ester. It's going to put two new ethyl groups on what used to be the carbonyl. First time you add an ethyl group, we'll make a ketone. I'll show you how. We've got spectator ion here. Ethyl group has a minus charge, and that's what makes it a nucleophile. Step 1 in red. We attack and the pi electrons break, become a lone pair on the oxygen, blue second. And we've got a lone pair, and it's coming back. Leaving group leaves. And this guy up here doesn't need to be drawn until the very end of this whole stream here. So what do we have here? We have R attached to carbonyl that has an ethyl on it. The R carbon also is attached to a carbon with a methyl, CH2, CH2, O minus. O minus will become OH when we use HCl, but that's not now. We have to get a second ethyl group on. So you better use your ethyl magnesium bromide twice before you use HCl. So we're going to hit the carbonyl, which is a ketone, with another ethyl group. Lone pair, minus charge. And the mechanism's almost done. Got your O minus. Got your O minus here too. Yeah, two new ethyl groups. Oh, I don't know why I typed a Z. Control Z is what I wanted, that's it. There we go, two new ethyl groups. If I had to guess which one's a better base, I'd be hard pressed. So as long as you show, you know, both HCl steps aren't happening at the same time, it's fine. Just don't do them all in one color. So here's one that's going first. Just I randomly selected that one to go first. And if that one's first, this one's second. And you're done. There you go. And as I told you on test 1, hemiacetal and acetal formation mechanisms will be on every exam. I usually don't tell you after the first exam. I just say, I said it, but here we are. We're making an acetal. We better have 2 alcohols and a carbonyl. Check. Alcohol number 1, alcohol number 2, and a carbonyl. First step is to protonate the carbonyl to make it a better electrophile. We called it activating the carbonyl. Second step, one of the alcohols attacks, and better be a different color. Here it comes. Coming in from way over here. We're going to generate an oxonium ion. Why not? I was going to third step it, but I'm out of room up there, so I'm not going to third step it. We got H bonded to O with a new bond to a carbonyl that's not a carbonyl anymore. An OH. All right. What else is attached to that O? We have a CH2 once, twice, 3 times with a methyl. 4 times to an R group. 5th is to an O, to a C with an OH, and 2 ethyl groups. And we have a Oxonium is promised. We have to neutralize our oxonium. And then we have to kick off our leaving group, but it's not a good leaving group. Let's do those two things. Neutralize your oxonium using the sulfate ion you just generated. Neutralizing the oxonium. Making the alcohol a better leaving group with the sulfuric acid you just generated. Make that a better leaving group. Step 2. And let's do it. The only thing I really don't love about how I did this one is I never really drew the hemiacetal. I mean, the species before is the conjugate acid of the hemiacetal, so I'm not terribly upset. I mean, it's a hemiacetal with an extra H on it, right? So yeah, we got a new H on here. Good leaving group. Perhaps it's time to have something leave. We have an O. Stage 2, once, twice, 3 with methyl, 4 with R, 5 with ethyl, ethyl, O, H. Yeah, I'm looking ahead here. Thinking about that ring, obviously. What's going to kick off that leaving group? It needs a little help. This is what's going to kick it off. You're going to generate an oxonium ion. And here's the oxonium ion. Stage 2 once, twice, methyl, R. O with an H, ethyl, ethyl. Go green. Yeah, sorry. These things slip out sometimes. What do we have here? Yeah. Oxonium. Starting to look a lot like this thing up here. Oh, there's going to be a deep protection later. Yeah, nice. I think we can get finished. Attack to make the second bond to O. It's an activated carbonyl, I hope you see. Just like right before you attacked it here. You activated it here and got attacked it with an alcohol. Here you got an activated carbonyl attacking with an alcohol. You're going to get an oxonium, right? Oxonium right here, it needs to be neutralized. What's going to neutralize it? Well, sulfate ion. We got sulfate ion way back here. Lurking. Oh, can't be red though. Second step. It's got to be a strong acid before you can take the H off. Yeah. All right, now it's time for hydrolysis. Hydrolysis of a different acetal. This acetal is much easier to hydrolyze than this. Must be. It comes off. And what are we going to make here? Well, let's see. This has to leave this OH. It's not an OH right now. That's a big hint, isn't it? When it leaves, it has an extra H on this O. Yeah. Let's put an extra H on that O, shall we? Make it a better leaving group. Then make it leave. How are we going to do that? Well, the other lone pair up here is going to make it leave. I like it. There we go. Let's draw what we get. Trying to figure out where I'm going to fit this. It looks like we can do a new R. Let's go with mellow pink. And I think there's your R. prime, then what we're going to get is our prime. Where are you? There you are. Our prime is attached to, let's see, OH, correct? OH. And that is that. Plus, plus, we have our cyclic oxonium. And a couple steps are going to get us to the finish line. Hello? I know what time it is. And we need, where's that O going to come from, everybody? Oh, this O down here. How about water? Oxygen and water, yeah. I would draw the H bonded to the O and show a bond there. Sulfate ion we made right here. We're going to use it. HO3SO minus. Can't use it right away. Lone pair on that is going to attack. Well, let's put the lone pair on top. So we're going to attack right there. Pi breaks, becomes sigma. And baby blue. We're almost done. Neutralize the oxonium. There you go. So don't forget, this is the leaving group from a DHP protected alcohol. Wow, that's a lot of stuff. As promised, you will be doing acetal formation on every test. And the opposite of acetal formation, also an option, that's hydrolysis. So yeah, acetal is very important, and hydrolysis is very important. Just think of that next time you're running low on energy, your body has to break into your glycogen stores, and it does hydrolysis of glycogen. You're doing this very reaction, just to get some energy to finish that test. All right. So yeah, there's certain review reactions that are so important, I make you do them all the time. Chromic acid oxidation also comes to mind, right? Okay, so we'll figure out what's next.